In this section, we're going to talk about the boundary layer theory for momentum, heat, and mass transfer. I'm very excited for this section because I feel like a lot of people are confused and a lot of people don't understand what boundary layers are. And this is a moment for us to bridge this gap and understand what we need so that we can move forward. The following example shows a simple fluid flow over a flat plate. Now you have the fluid flow over here. It has a particular free stream velocity. And when I say free stream velocity, I mean it has a particular bulk velocity that it was traveling at before it gets to flow and become in contact with the plate. And it obviously has a particular free stream temperature. Now, as the fluid approaches the leading edge of the flat plate, so that means as the fluid approaches the beginning of this flat plate, it has a uniform free stream velocity, which we just said, and a particular temperature. So you can think of this as the initial velocity and the initial temperature before it flows and makes contact with the flat plate. Now, upon contacting the plate surface, the fluid velocity at the wall becomes zero, and this is due to the no-slip condition. And then you have a velocity boundary layer that begins to develop from the leading edge of the flat plate. Now, the no-slip condition is something that you might have learned from your fluids mechanics course, but essentially this condition allows you to assume that the velocity at the surface itself is as low as zero. And then because of that, you start developing a velocity gradient, which we're going to talk about in a minute. In terms of the fluid temperature, if a temperature difference exists between the plate and the fluid, then you also have a thermal boundary layer that also begins to develop at that leading edge. Now, if the plate is hotter than the fluid, then the heat is transferred from the surface to the fluid by molecular diffusion, and it begins at the surface and it propagates in the y direction. And then you also have the bulk fluid motion that then carries that heated fluid downstream along the plate in the x direction. So we're going to look at these two components of the heat transfer. So you have heat transfer in the y direction, which is because of the diffusion, the viscous diffusion that's occurring. And that's because of the no-slip condition. So as the velocity of the particles near the wall becomes zero and they interact with the other molecules adjacent to them, then they start colliding with each other and you have a net exchange of momentum. And so you'll see that the area near the wall is impacted by the influence of the no-slip condition and of the wall. And we're going to dive deep into that. So let's continue with the same example and discuss the velocity boundary layer first in more detail before jumping into the thermal boundary layer.